Hello and welcome to today's lesson on finding the nth term of a quadratic sequence. Now if you haven't seen the video on finding the nth term of a linear sequence, it's probably worth watching that first. So let's just start off with our first example. So let's make it big so you can see it. So example 1. Now there is a slightly different technique with this one here. And with this one here, you've got to find something which is called the second difference. And you'll see what I mean by that in a second. So here we've got our first term, which is 2, 5, 10, 17, and 26. Now you might think to yourself, how do I know that this is a quadratic sequence and not a linear sequence? Now, the first thing you do when you're finding a linear sequence is you find the common difference. If you have seen that video, I used the word deno to find the difference and then the nth term and then the 0th term from before. So with this one here, when I do that, and I find the common difference here, well, from 2 to 5 is 3, 5 to 10 is 5, 10 to 17 is 7, and 17 to 26 is 9. So the problem here is that it's not going up by the same thing each time. So straight away I know that it's not a linear sequence. Okay, so this is what's called the first difference. Okay, that's the first difference. So what we need to do when we're doing a quadratic sequence is we find the second difference. Now with the second difference, again we just find the amount is going up by here. So from there it's 2, here it's 2, and here it's 2. Brilliant, so my second difference is 2. Now, the thing that we need to know is we know that they're always in the format, quadratics are well I'm going to use the word n now because it's the nth term I'm trying to find, an squared plus bn plus c. So something n squared plus something times n plus something plus c. Okay, so this is the format that they come in. Now with this one here, the thing that you need to know, and it's definitely worth getting this down in your notes, is that the number in front of your squared value is half the second difference. So I'm going to write that down. It's definitely worth writing that down as well. The number in front of n squared is half the second difference. Okay, the number in front of the n squared is half the second difference. So in this case here, the first thing that I need to know is it's half of that, which is 1, so it's going to be 1n squared. Now I know that I don't put 1 in front of things, I just write 1, let's say. So straight away, I know that it's going to be n squared. Okay, I know it's going to be n squared plus something else. Now, the way that I do this, okay, is I write down here n squared. Okay, I write the sequence above it, which in this case is that one up there, which is the sequence I want. So it's going to be 2, 5, 10, 17, and 26. Now, I know that it starts off with n squared. But I want to find out what the rest of it is. So if I want to find out what the rest of it is, I need to take away this n squared from my original pattern. Because if I take the n squared away, I'm just left with that last part. So here, you need to work out what the pattern for n squared is. Now remember, hopefully you've watched a video on potentially substituting into a value. If I want to find out the sequence for n squared, I need to sub in 1 for the first one, then 2, then 3, then 4, then 5. So if I sub in 1 into this, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So, when I do this, remember I want to subtract from this here, subtract from that n squared to find out what that leftover pattern is. So I do 2 take away 1, which is 1, 5 take away 4, which is 1, 10 take away 9, which is 1, 17 take away 16, which is 1, and notice that this pattern is just 1, which means that there's just 1 left over here. So with this one here, I know that I've got the n squared, and then when I've got the rest of it, the only thing which is left is this one. So my sequence is n squared plus 1. Okay, so just to go through some of the parts here. With a quadratic sequence, the first thing we notice is the first difference isn't the same. It's not increasing by the same value. So we need to find the second difference. When I'm finding the second difference, we know that a quadratic sequence comes in the form an squared plus bn plus c. This is what a quadratic sequence is in the form of. Now, to find out what this a is, the number in front of the n squared is half the second difference. So half of 2 is 1, so that's going to be 1n squared. And then to find out what's left over, we subtract the squared term from our original sequence to see what's left over. So in this case, when I subtracted it, what was left over was just 1, which means that it's going to be n squared plus 1. Okay, so what I'm going to suggest is maybe have a little go at that one on the right hand side. So pause now and have a little go at that one on the right. Okay, I'm going to go through this one now then. So this one here is example 2. So example 2, and what have we got? We've got 0, 3, 8, 15 and 24. So the first thing I need to do is to see whether it's a linear sequence or a quadratic sequence by finding that first difference. Now with this one here, it's 3, 5, 7, 9. So straight away I can see that it's not a linear sequence because it's not going up by the same amount each time, which means I need to find the second difference. Second difference is 2, 2 and 2, same as the last one, which means that I halve this value. The number in front of the n squared is half the second difference, so half of 2 is 1, so straight away I know it's going to be 1n squared, but I don't write 1n squared, I just write it as n squared. So that's my first stage. The next stage here is to subtract the n squared away from my original sequence. So I write my original sequence down, which is 0, 3, 8, 15 and 24. And then I work out what the sequence would have been just for n squared. So 1 squared is 1, 2 squared is 4, 2 times 2 is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Brilliant. So then I need to take this sequence away from my original sequence. So take away n squared here away from my original sequence. Now it's worth putting a line under here. Now do be careful for this. You always want your original sequence on top and then your n squared sequence below. And remember, you're subtracting them. Because here, 0 take away 1 is minus 1. 3 take away 4, again, is minus 1. 8 take away 9 is minus 1. 15 take away 16, it's minus 1 the whole time. So I knew that it was n squared, like so. So I'm going to write down n squared. And then what's left over if I've taken that away from my original one? Well, in this case, it's minus 1. So it's n squared minus 1. So let's just check those two answers. N squared plus 1 and n squared minus 1. Okay. Now, this here, where it was plus 1 and minus 1, now, usually it's not just a single value like that. Usually it's an extra sequence that happens here. And we've actually got to find out what that extra sequence is. So that's what we're going to have a little look at next. So these type of questions usually come up in the higher paper. They're very, very common. It's a case of it's one of these things that if you learn it, you guarantee those marks. So it's worth remembering it because this does come up very regularly. Okay, so let's have a look at this one on example 3. So example 3, and example 3 is 2, 7, 14, 23, 34. So the first thing I need to do is find out my first difference. Well, 2 and 7 is 5. 7 to 14 is 7. 14 to 23 is 9, and then that is 11. So it's going up. So we notice it's not the same here. So I need to do my second difference, which in this case is 2, 2, and 2. Brilliant. Now remember, the number in front of the n squared is half the second difference. So in this case, my second difference is 2. So the number in the front of the n squared is going to be 1. So I just write n squared. The next stage is I need to subtract n squared from my original sequence. So I write down original on top. My original sequence is 2, 7, 14, 23, 34. N squared. Well, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. So when I subtract this, okay, 2 take away 1 is 1. 7 take away 4 is 3. 14 take away 9 is 5. 23 take away 16 is 7. And 34 take away 25 is 9. Notice here, it's not the same as the last one because they're not all the same value. So it's worth thinking about it. It's like you've got a sequence within that sequence. So I find out what my nth term is for the n squared, and then I've got another sequence within that, which is this linear sequence. So once I've got that linear sequence, then I can use deno, if you want. I think that's the easiest method, okay, for this one, to find out the nth term for this. So when I'm finding out the nth term, I find out the common difference of this one, which is plus 2, plus 2, plus 2, which means that it's going to be 2n. And then remember, for my deno, I find my 0th term as well. So minus 1 there. Minus 2 there, sorry. 1 minus 2 is minus 1. Okay, so it's 2n minus 1. Now I haven't finished there, because I've now got to bring all of these things together. The squared part, the linear part. So my final answer for this is the squared part of my sequence. This is the linear part of my sequence. So altogether, it's going to be n squared plus 2n minus 1. Super. Okay. So that was example 3. It's quite complicated. There's a lot of steps going on there. You've got to find the second difference. Half of the second difference is the number in front of n squared. Then you've got another linear sequence within that we've got to find out using deno. Okay, so that there was example 3. Let's have a look now at example 4. If you're feeling confident, pause now and have a go at example 4 yourself. I'll make it big for you so you can do that. So pause now and have a go at that one on the right if you're feeling confident. Okay, I'm going to go through it anyway now. So example 4, I would really suggest getting these down in your notes. This isn't an easy task. Remember, the only way to learn maths is to actually do it. So do make sure you're getting this one down. So it's 5, 11, 19, 29, and 41. So what am I going up by each time? So the first one is 6. This one here is 8. This one here is 10. And this one here is 12. So my first difference isn't the same. So I find out my second difference, which in this case is 2. Remember, I halve my second difference, and that's the number in front of my n squared. So half of 2 is 1. So it's going to be 1n squared. I also need to write out my original sequence. So my original sequence is this one: 5, 11, 19, 29, 41. My n squared sequence is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So first, second, third, fourth, fifth term. Brilliant. Then I'm subtracting these, remember, my original away from my n squared away from my original. So 5 take away 1 is 4. 11 take away 4 is 6, 7. 19 take away 9 is 10. 29 take away 16 is 13. And 41 take away 25 is 16. Notice that this isn't just one number, so it's a sequence within a sequence. So then I need to find out the linear part of it, and I do that by looking at this. So what is this part? Well, it's plus 3, plus 3, plus 3. So it means it's going to be 3n, but then I need to find out what my 0th term is. So minus 3. So 4 minus 3 is 1. So 3n plus 1. Then I need to bring the quadratic part and the linear part together. So in this case, it's going to be the n squared and the linear part. Final part of this is n squared plus 3n plus 1. Super. So let's check those answers. N squared plus 3n plus 1, n squared plus 2n minus 1. Absolutely super. So, let's have a look at the next questions here. Now, I've done some more which are very similar here, because I think practice makes perfect with this one. Okay, so this one here now is example 5. If you want to pause and have a go at this, pause now and have a little go. Okay, I'm just going to, in fact, maybe I'll make it big for you so you can see it first. I'm just going to get stuck into this one. So this one here is example 5. And my sequence is minus 3, 1, 7, 15, 25. So, same as always. First difference, second difference, half of that. So my first difference here is 4. 1 to 7 is 6. 7 to 15 is 8. 15 to 25 is 10. So my first difference isn't the same, so I'll work out what my second difference is, which is 2. Now, they've all been 2 so far. We're not all always going to be 2. There are going to be some which are trickier. We'll look at those in a second. So half this number here, and that goes in front of the n squared. So in this case, half of 2 is 1, and 1 n squared, so just n squared. And I also write my original. So my original was minus 3, 1, 7, 15, and 25. So n squared, 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16, and 5 squared is 25. Then I work out my common difference. Sorry, then I subtract these. So minus 3 take away 1 is minus 4. 1 take away 4 is minus 3. 7 take away 9 is minus 2. 15 take away 16 is minus 1. And 25 take away 25 is 0. So we have got a pattern there. So then I work out what my linear part of this is. So what's it going up by here? Well, it's going up by plus 1 each time, isn't it? Which means that it's I'm not going to write 1n, but it would be 1n. It's just n. 1n. And then remember, I need to find my 0th term by going backwards here. So minus 1. So 4 minus 1 is minus 5. So it's n minus 5 there. Remember, I need to bring my quadratic and my linear part together. So that's going to be n squared plus n minus 5. Super. Let's check that answer. Let's have a little look. Make sure I'm right. N squared plus n minus 5. Brilliant. So, we're going to get a little bit harder now. Not that much harder. You'll see why. So, I'll make this big for you so you can get that first one down. So, here are the first 4 terms of a quadratic sequence. Find the nth term in the form an squared plus bn plus c. So it's actually giving you the formats here. Notice this is 4 marks, which means this has actually come up on a past paper question. Okay, so this is from the GCSE. Okay, so let's have a look then. So this one here is example 6. Do make sure you're getting these down. So let's write it down. So 2, 15, 34, and 59. So the first thing I'm going to do is see what it's going up by each time. So from 2 to 15 is 13. From 15 to 34 is 5, 15, 19. Yeah, good. 34 to 34 to 59 is, I think, so let's go up. 6 is to 40. 6 is to 40. Another 10, so 16 to 50, and then another 9. So that is 21. No, 34, mate, sorry. 34 is 6, then plus another 10 is 16, then plus another 9 is 16 plus 9 is 25. Oof. Some terrible mental maths there. Alright, and then I find the second difference of this. So 19 take away 13 is 6. And then 25 take away 19 is also 6. Right, what am I noticing here? Well, I'm noticing this is my first difference. This is my second difference. My second difference isn't 2 this time, it's 6. Now remember I said the number in front of n squared is half of this value here. So in this case, half of 6 is 3. So it's going to be 3n squared. Okay, half of that second difference in number in front of that n squared. I write down my original sequence, which in this case is 2, 15, 34, and 59. Now, you've got to be super careful with this. Chances are this has probably come up on a calculator paper. Okay, so when I'm doing this, but if it doesn't come up on a calculator paper, you've got to be really careful, because when you're substituting in, you must make sure you do the indices first and do the squared first and then times by 3. Now I am going to use my calculator here. So I'm going to use mini brackets. So remember, my first term I'm subbing in 1, my second term I'm subbing in 2, third term I'm subbing in 3, fourth term I'm subbing in 4 to this squared value here. So my first one is 3 bracket 1 bracket squared. Just like that. So 3n squared, 3 times 1 squared is 3 in this case. So the next time I'm going to sub in 2 for my second term. 3 bracket 2 bracket squared. Just like that. So my second term. So that one there is 12. And then 3 bracket 3 times all squared there. So 3 times 3 squared is 27. And then 3 bracket 4 all squared, just there like that. So that there is 48. Now remember, you're subtracting your original, your squared values away from your original. So I'm subtracting all of this. So it's going to be 2 take away 3, which is minus 1. 15 take away 12, which is 3. 34 take away 27, which is 7. And 59 take away 48, which is 11. So I've got my quadratic part here. I've got this 3n squared, and now I've got my linear part, and I've got to find out my linear part. So I'm going to use Dino for that, the difference and the 0th term. So what am I going up by here? Well, I'm going up by 4, aren't I? 4, 4, and 4, which means that it's going to be 4n. And then I find my 0th term by going back 1. So minus 4 minus 1 minus 4 is minus 5. So 4n minus 4 is minus 5 there, like so. Now remember, I'm bringing my quadratic part and my linear part together. So my final answer here for this one is 3n squared plus 4n minus 5. So very, very tricky there. Now it does say find the values of a, b and c. Now notice here, this is the quadratic. So an squared, so a is equal to 3. bn, so plus the 4. And c is this minus 5. Brilliant. Super. So that is trickier. There's a lot going on there. It's taking a whole page there. Let's just very quickly run through it again. So first difference, second difference. Super. Then we halve the second difference and that number goes in front of the n squared. Then we subtract that from my original sequence. Then I'm left with a linear sequence and I find out the sequence for the linear one. And then I bring my quadratic and, my squared and my linear parts together. Super. Okay, so let's have a look at this one on the right. I'm going to make it big. I'm going to suggest that you pause and have a little go at that now. Pause and have a little go at that. Okay, let's go through it together then. So this one here is example, what example am I on? Example 7. I always forget what example I'm on. So, example 7. Super. So my sequence is 6, 11, 20, 33, and 50. So, find my first difference first. So 6 take away 11, 11 take away 6, it's gone up by 5, 20 take away 11 is 9, 33 take away 20 is 13, and 50 take away 33 is 17. So it's not going up by the same thing, so I find my second difference here, which is 9 take away 5, which is 4, 13 take away 9, which is 4, 17 take away 13, which is 4. Brilliant. So this is my second difference. Super. Now remember, the number in front of your n squared is half of the second difference. So in this case here, it's going to be 2n squared. I also write down my original sequence, which was the 6, 11, 20, 30 and 50. So with this one here, remember, if it's non-calculator, you do the squared first, then times by 2. And we're subbing in 1, then 2, then 3, then 4. So the first one is 2 bracket 1 times all squared, just like so. Which is going to be 2. 2 times by 2 all squared, which is 8. 2 times 2 all squared is 8. 2 times by 3 all squared, which is 18. 2 times by 4 squared is 32. Remember, look, I'm using the mini brackets there. Last one, 2 times by 5 squared, which is 50. Super. So I'm then subtracting my original from, my 2n squared from my original to find out what's left over. So 6 take away 2 is 4. 11 take away 8 is 3. 20 take away 18 is 2. 30 take away 32. 30 take away 32. Let's just check that. Okay, just spotted what little mistake I've made. Look, this is 33 and I put 30 there. What a silly Billy. How did I spot that? Well, I did 30 take away 32 and it was minus 2, which didn't follow this pattern, so I knew that it was wrong. So 33 take away 32 is 1, and 50 take away 50 is 0. Super. So I've got my squared part, and then I need to find my linear part, which is this part here. So what's happening here? Well, it's going down by 1 each time. So minus 1, minus 1, minus 1, minus 1. So it's going to be minus n. Then I find my 0th term by going the opposite way. So plus 1 here. 4 plus 1 is 5. So plus 5. Super. Then I'm going to bring my quadratic and my linear parts together, which is 2n squared minus n plus 5. Brilliant. So let's check both of those answers. 2n squared minus n plus 5. And it was 3, 4 and minus 5. Brilliant. Okay, so last question here. Now, this is only very slightly different. There's not really that much difference here. The only thing that's different is they're doing it in terms of a pattern. Now, we've seen this if you've watched the nth term video towards the end. So it says here we've got 3 towers, and it's actually giving you the size of the towers. So tower 1 is 1, tower 2 is 5, tower 3 is 13, tower 4 is 25. Now, your starting point with this is it's saying find the nth term. So we've got to find the nth term of this. Now it's actually already given you the term values, so it's just starting with that. So 1, 5, 13 and 25. Now I think you can probably do this yourself by now. So if you want to pause and have a go at that, then do that. I'm just going to carry on with it. So 5 take away 1 is 4. 13 take away 5 is 8. 25 take away 13 is 12. Then I'd work out my second difference, which in this case is 4 and 4. Remember that the number in front of the n squared is half of the second difference. So half of this 4, which is going to be 2. So it's going to be 2n squared. And I also need to write down my original sequence, making sure it's right, okay? So let's write down my original 1, 5, 13 and 25. And then I'm subbing in here 2 times 1 all squared, which is 2. Look, I'm subbing in 1 into there. 2n squared, 2, 1 squared. Make sure you're using the mini brackets there and doing the squared on that top side there. So the next one's going to be 2 times 2 squared. Look, there's my next one, subbing in 2, which is going to be 8 in this case. 2 times by 3 squared, which is 18. Last one, 2 times by 4 squared, which in this case is 32. And then subtract my squared term away from my original sequence. So 1 take away 2 is minus 1. 5 take away 8 is minus 3. 13 take away 18. 13 take away 18 is minus 5. And 25 take away 32 is minus 7. So then I've got to find out what my linear part is. Last little part, we're getting there now. So what's happening here? Well, it's decreasing, isn't it? So it's minus 2, minus 2, minus 2. So it's going to be minus 2n. And then what's my 0th term? So plus 2 here. 1 minus 1 plus 2 is positive 1. So plus 1 there. Brilliant. And then I'm bringing the last little part, my squared term and my linear parts together to get 2n squared minus 2n plus 1. Super. Let's check that. 4 marks. That's come up on a past paper. That. In fact, that actually came up on a very recent past paper. So that one there is 2n squared minus 2n plus 1. Absolutely super. 4 marks. So here's some questions. So I'll make this big. Pause now and have a little go at that one yourself. Here you go. Pause now and have a go at those questions. Super. So mark those in green. Mark them in green. Brilliant. So thank you for watching this video on quadratic sequences. A lot of steps in that one, so you do need to make sure you're having a go at it. Remember, the only way to learn maths is to do it, and have a lovely day.